conceptual approach to study organic chemistry. This is question bank 2. First question is, find out the functional groups present in following compound. These are some compounds given. One by one I will take the structure of these compounds. First is penicillin. This is the structure of penicillin. Find out the functional groups present in this compound. From one side, when you analyze this particular penicillin, you will find RCONHC. This part is secondary amide. CCONHCC. This part is tertiary amide. CCOOH. This part is carboxylic acid. And CSC. This part is thioether. For second molecule, nicotine, one part is pyridine, and second, here nitrogen is attached to three-sided carbon. This part is tertiary amine. Third, the main chemical Dettol. Here OH group is attached to benzene as well as chlorine. So this particular part in which OH is attached to benzene, it is phenol, and when Cl is attached to benzene, it is chlorobenzene. When CH3 is attached to benzene, it is commonly called as toluene. In case of aspirin, benzene is attached to COOH group, that is this particular part is benzoic acid, and here CCOOPH, that is ester, phenyl ester. In case of paracetamol, when you carefully analyze the functional groups, CCONHC, this part is phenyl and phenylamide, and here OH is attached to benzene, it is phenol. In case of indigo dye, here CCOC, this particular part is ketone. CNHC, this particular part is secondary amine. Here again CCOC, this part is ketone. CNHC, this part is again secondary amine, and in this case it is carbon-carbon double bond, that is alkene, along with molecule have benzene ring. In case of sulfur drug, this particular part is furan. Here carbon is attached to NHC. This particular is secondary amine, chlorobenzene, carboxylic acid, and here sulfonamide. Sulfonamide is a group in which carbon is attached to SO2NH2. In case of Viagra, this particular part C, C and C, that is 3 carbon is attached to N, it is tertiary amine. Here sulfonamide, COC, this part is ether, along with heterocyclic ring. In case of testosterone, molecule have carbon-carbon double bond, alkene, CCOC, ketone. Carbon is attached with OH, it is secondary alcohol. In case of cocaine, this particular nitrogen is a part of bicyclic ring in which nitrogen is attached to 3 carbon. It is tertiary amine. CCOOC, this part is ester. Here again CCOOC, this part is again ester group. So these are the functional groups present in these compounds. Second question, what is functional group and why they are important in organic chemistry? Functional groups are the sites of chemical reaction where chemical reaction has to take place. They help to categorize the molecule into different family and also help in nomenclature of compounds. If a molecule have COOH group, it is called as carboxylic acid, and the nomenclature of that carboxylic acid have oic acid. What are homologues? Homologues are the group of organic compounds which have same type of chemical reaction. This is important. Homologues must have same type of chemical reaction, and they differ in CH2 n units and may vary from 1 to infinite. That is all alkene, whether it is methane, ethane, propane, butane, pentane, hexane, heptane, all alkenes are homologues. But when question is asked next higher homologue, that means the value of n is 1. That is, molecule must have difference in CH2 unit. That is, they have difference in 14 atomic mass. But when only question is asked about homologue, in that case all the molecules of same family which have same type of chemical reactions are called as homologue. That is, all alkenes, all carboxylic acids, all aldehydes and all ketones are the homologues. Name the compound in which OH group is attached to tetrahedral carbon, carbon-carbon double bond, aromatic ring and CO group. When you carefully analyze the molecules, when tetrahedral carbon is attached to OH, such as this molecule, it is called as alcohol. But when OH group is attached to carbon-carbon double bond, it is called as enol. En for carbon-carbon double bond and ol for alcohol, enol. But when OH group is attached to benzene or phenyl group, it is called as phenol. Phenyl plus ol, it is phenol. When OH group is attached to CO, it is called as carboxylic acid. So a student must know the attachment and name given for the molecules when OH group is attached to tetrahedral carbon, carbon-carbon double bond, aromatic ring or CO group. Find the total number of primary, secondary, tertiary and quaternary carbon in given molecules. Primary carbon is that one in which none or one carbon is attached to carbon. Secondary carbon is that one in which carbon is attached to 2 carbon. Tertiary carbon is that one in which carbon is attached to 3 carbon, while quaternary carbon is that one in which carbon is attached to 4 carbon. First molecule, look for this. Question is, find the number of primary, secondary, tertiary and quaternary carbon. Answer is this. Look for this carbon. This carbon is attached to 1 carbon, so it is primary. This carbon is attached to 2 carbon, it is secondary. This carbon is attached to 3 carbon, this one is tertiary, and again these two are the primary carbon. For this molecule, find the number of primary, secondary, tertiary and quaternary carbon. The answer is this one. Carefully analyze. These carbon are the primary carbon. This carbon is tertiary nature, again tertiary is nature, quaternary, tertiary. This molecule do not have any secondary carbon. Look for this molecule. This carbon is primary. Look for this carefully. This carbon is attached to 2 carbon. One side have nitrogen. So this carbon is secondary, tertiary, primary, primary. This carbon is again tertiary because this carbon is attached to 3-sided carbon. Another part, 4th valency is attached with OH. This carbon is secondary in nature because this carbon is attached to 2 carbon. One is chlorine. This molecule have these primary carbon, these are secondary carbon, and this is tertiary, and this one is the quaternary carbon. For this molecule, this is primary, primary, primary. Again this one is also primary carbon because this is attached to one carbon. This is oxygen. This one is tertiary because one side is oxygen. Secondary, secondary. This one is the tertiary carbon. Look for this molecule. This is primary carbon. This is again primary carbon because it is attached to oxygen. This is primary again. This one attached with two-sided carbon, so it is secondary, not tertiary. This is attached to one side carbon. Here another part is the nitrogen, so it is also primary carbon. This is tertiary, secondary. This is attached with two carbon. It is also called as secondary. For this molecule, this is attached to two carbon. This is secondary, this one is primary, secondary, secondary. Analyze for this carbon. It is attached to two carbon. One side is nitrogen, so it is again secondary, secondary, secondary. This one is attached to three carbon, so it is tertiary. This is secondary and this one is the primary. This one is again primary because it is attached to one carbon. One side is the nitrogen. Analyze for this molecule. This carbon is primary in nature. This carbon is again primary in nature. This is again primary. This carbon, one carbon, one carbon. One is oxygen. This one is secondary. This is attached to two carbon, secondary. This is attached to three carbon. It is tertiary. This carbon is attached to two carbon. One is nitrogen, so it is again secondary. This one is attached to two carbon, secondary. This is attached to two carbon, secondary. Again attached to two carbon, secondary. This one attached to two carbon, secondary. Tertiary. Here carbon is attached to two carbon. It is secondary. In which carbon is attached to one and two carbon. It is also secondary. This carbon is attached to two carbon. It is also secondary. Find the total number of primary, secondary, tertiary hydrogen present in given molecule. Primary hydrogen are those hydrogen which are present over primary carbon. Secondary hydrogens are those which are present over secondary carbon, while tertiary hydrogen is that one which is attached to tertiary carbon. There is no quaternary hydrogen. So carbon is a 4 type: primary, secondary, tertiary and quaternary, while hydrogen is a 3 type: primary, secondary and tertiary. For this molecule, this is primary carbon, primary carbon, primary carbon. So 9 primary hydrogen. This one is secondary carbon, so 2 secondary hydrogen. This is tertiary carbon and have 1 hydrogen. So number of hydrogen here is 9 for primary, 2 for secondary and 1 for tertiary. For this molecule, primary hydrogen is 15 because this molecule have 5 primary carbon. This particular is tertiary carbon, 1 hydrogen, and molecule do not have secondary carbon, so no secondary hydrogen is present in this molecule. Primary carbon, secondary carbon. This is again secondary, secondary, secondary. This is tertiary, primary and primary. So count the number of hydrogens present over primary carbon, secondary carbon and tertiary carbon. This carbon is tertiary in nature, but this does not have any hydrogen. So molecule may have tertiary carbon but no hydrogen, but molecule may have tertiary carbon with 1 hydrogen. In case of hydrocarbons, primary carbon have 3 hydrogen, secondary have 2, while tertiary have 1 hydrogen. But in case of substituted molecules, Primary carbon may have 3, 2, 1 or 0 hydrogen. Similarly, secondary carbon may have 2, 1 or 0. Tertiary may have 1 or 0 number of hydrogen. For this molecule, number of primary hydrogens are 9, secondary hydrogen 8, 2, 2, 2, head 2, tertiary is 1. For this molecule, analyze the carbon first. This is attached to 2 carbon, secondary carbon, secondary, tertiary, secondary, primary. This is primary carbon. So answer is number of primary hydrogen 8, secondary hydrogen 4, tertiary is 1. Find the total number of chemically different hydrogen present in given molecule. Chemically different hydrogen are those which on chemical reaction leads to compound with different IUPAC name. Analyze for this molecule. This is pentane. Answer is 3, because if you replace this hydrogen with Cl, the molecule will be 1-chloropentane. When you replace hydrogen of this with Cl, molecule will again 1-chloropentane. So hydrogen present over this position and hydrogen present over this position have same chemical reaction. Over this carbon and this carbon again have same chemical nature, that is on replacement with chlorine they give 2-chloropentane and here 3-chloropentane. So molecule have 3 type of chemically different hydrogen. From this position 1-chloro, from this position 2-chloro, while from this position 3-chloropentane are observed. For this molecule, this molecule have 4 type of chemically different hydrogen. When we replace hydrogen from this position, this is 1, 2, 3 and 4, you will get 1-chloro-2-methyl-butane. From this position 2-chloro-2-methyl-butane. From this position this is 1, 2, 3 and 4, so 2-chloro-3-methyl-butane. From this position 1-chloro-3-methyl-butane. From this position again, if you replace hydrogen, it is 1, 2, that is 1-chloro-2-methyl. So the hydrogen present over these two positions are having same type of chemical reaction. So hydrogens are also chemically same. So total number of hydrogen which are having different chemical reactions are 4 from one position, second, third and fourth. For this molecule, all the hydrogens are chemically same. If you replace any hydrogen with chlorine, you will obtain chlorocyclopropane, chlorocyclopropane, chlorocyclopropane. For this molecule, if you replace hydrogen from this position, you will get chloromethyl cyclopropane. From this position, you will get 1-chloro-1-methyl. From this position, 1-chloro-2-methyl. So molecule have 3 type of chemically different hydrogen. Hydrogen present over this carbon and this carbon have same chemical nature. For this molecule, the answer is 3. These hydrogens have same chemical nature, these have same, while this particular have different. So 1, 2 and 3. For this molecule, answer is 2. These 6 hydrogens have same chemical nature and these 4 hydrogens have same chemical nature. No hydrogen is present over this particular position. So this molecule have 2 chemically different hydrogen. For cyclobutane, answer is again 1, similar to cyclopropane. In this molecule, all CH3 groups have same chemical nature, while all hydrogen present over the ring have same chemical nature. So this molecule have two chemical different hydrogen. Carefully analyze this molecule. CH3 present over this carbon and CH3 present over this carbon have no same environment, so the hydrogens are also chemically different. So 1 from this position, 2, 3, 4 and 5. These two carbons are also chemically different. So hydrogen present over this is also different, because this carbon is attached to the carbon which have one CH3, while this carbon is attached to the carbon which is having two CH3 group. So hydrogen present over this position and hydrogen present over this position have different chemical nature. Analyze for this molecule. This CH3 and this CH3 have different environment, so hydrogen present over this are also chemically different. 1, 2, these two are same, 3, 4, 5 and 6. For this molecule, analyze carefully this CH3 and this CH3, whether they have same environment or different. This CH3 is attached to the ring, one side carbon with methyl, while another side carbon having no methyl. But for this carbon, both sides have carbon with methyl group. So environment of this carbon and environment of this carbon are different. So replacement of any hydrogen with any atom or group will give different chemical nature. So molecule have 1 for this and this, 2 for these two, 3, 4 and 5, because hydrogen present over this position and this position have same chemical nature. For this molecule, one, 2, 3, 4, 5 and 6. These two positions have different chemical nature. For this molecule, answer is 4. 1, 2, 3 and 4. Again, similar to cyclopropane and cyclobutene, cyclohexane have also all hydrogens chemically same. For this molecule, answer is 5. 1, 2, these two, 3, for these two position, 4 and here 5. These 6 hydrogens have same chemical nature. So 1, 2, 3 and 4. This carbon do not have any hydrogen. So answer is 4. Again, this position are chemically same, 1, 2, 3 and 4. For this molecule, answer is 5. Look for the difference of this carbon and this carbon. Hydrogen present over this carbon. The environment of this carbon and this carbon is different. So hydrogen present over this carbon is also different. But the environment of this carbon and this carbon is same. So it has 1 for these two, 2, 3, 4 and 5 positions where chemical reaction leads to different product. For this molecule, answer is 3. This CH3, 1, 2 for this carbon, and you carefully analyze all these 4 positions are same. If you replace hydrogen of this with Cl, the compound is 1 chloro 2 5 dimethyl. We replace this again, 1 chloro 2 3 4 5 dimethyl. Don't bother about nomenclature. Think for the attachment. In this molecule, answer is 7. 1, 2, 3, 4, 5, 6 and 7. This CH3 and this CH3 have different environment, so chemical nature are different. Find the total number of monochloro products obtained by following alkanes with stereochemistry. That is, if molecule will show geometrical isomer, then think for cis and trans, and if molecules are showing optical, then DL along with meso. For butane, monochloro, it means you have to replace one hydrogen with chlorine. When you carefully analyze and replace this hydrogen, you will get one chlorobutane with no stereochemistry. But when you replace hydrogen from this position and attach Cl, this particular carbon become chiral. So total number of monochloro product along with stereochemistry is 3. 1 for this position and 2, D and L for this position. For pentane, the answer is 4. 1 for this position, 2 for this position because of DL mixture, and again 1 for this position because ethyl groups are same over this position. So this carbon is not chiral, but this carbon is chiral. So answer is 4. For this molecule, carefully analyze. The answer is 6. 1 position, 2 because of DL mixture, 3, and if you replace hydrogen from this position with Cl, this carbon become chiral because when this is CH2Cl, so this carbon is CH2Cl, H, methyl and ethyl. All the 4 parts are different. So replacement of this hydrogen with Cl, this carbon become chiral. So 2 after replacement of this hydrogen, 1, 2 replacement of this hydrogen and 1. So total number is 6. For this, think geometrical also. Answer is 6. 1 for this position, no chirality. 1 for this position, no chirality. But when you replace hydrogen from this position, molecule will become 1-chloro-2-methyl. Molecule have chiral center and molecule will also show geometrical isomers. So cis and trans are possible, no plane of symmetry, center of symmetry, so molecule will be optically active. So DL for cis and DL for trans. So 4 for this position, 1 for this and 1 for this. Answer is 6. For this molecule, one, two because DL mixture is obtained from this position. Again 1, and here when you replace hydrogen from this position with Cl, cis and trans are obtained, no plane of symmetry, center of symmetry. So DL for cis, DL for trans. 4 after replacement of this hydrogen. 4, 5, 2, 7 plus 1, 8. For this molecule, answer is A. 1, 2 for this position, cis trans is obtained. Both have DL mixture. So 4, and here again when you replace hydrogen of this position with Cl, cis trans is obtained, but molecule have plane of symmetry, center of symmetry, so both are meso, so no DL. So answer is 8. For this molecule, cyclohexane, answer is 1 because no chirality. Replacement of any hydrogen with Cl give chlorocyclohexane as a product. But when I replace hydrogen of methyl cyclohexane with Cl, compound will give geometrical as well as optical. So answer this molecule is 12. 1 for this, 1 for this but replacement of this hydrogen with Cl, cis and trans is obtained. Both will show DL mixture. Replacement of this hydrogen with Cl will give cis trans, both have DL mixture, but replacement of this hydrogen with Cl gives cis trans, but molecule have plane of symmetry, so no C, D and L mixture. So total value is 12. Find the total number of dichloro product obtained by following compound. Don't think for stereo because it will take time. Just think for the structural isomers. Dichloro, in case of ethane, first replace one hydrogen, then second. So in this case you will get answer 2. One for 1 position and another for 1 2 position. For propane, the answer is 4. 1 for 1 1, another 1 2, another 1 3, and fourth one is the 2 2. This is 1 2 3. So 1 1, 1 2, 1 3, and 2 and 2. So answer is 4. For butane, answer is 6. 1 1, 1 2, 1 3, 1 4. This is 1 2 3 and 4. 1 1, 1 2, 1 3, and 1 4. Along with 2 2 and 2 3. This is position number 2 2 2 and 2 and 3. So total answer is 6. For 2-methyl butane, the answer is 10, because if you say 1 2 3 and 4, and for sake of simplicity it is 1 dash, so answer will be 1 1, 1 2, 1 3, 1 4 and 1 dash, that is 1 1, 1 2, 1 3, 1 4 and 1 dash, along with 2 3 and 2 4, with 3 3 and 3 and 4, along with 4 4. So total number answer is 10. For pentane, the answer is 9. This position is 1 2 3 4 and 5. So it is 1 1, 1 2, 1 3, 1 4 and 1 5. 1 1, 1 2, 1 3, 1 4 and 1 5, with 2 2, 2 3, 2 4 and 2 5. 2 5 and 1 2 2 and 5. Ignore 2 5. This is 1 1, 1 2, 1 3, 1 4, 1 5, 2 2, 2 3 and 2 4, with 3 3. So total answer is 9. For cyclopropane, the answer is 2. 1 for 1 1 and another for 1 2 position. For cyclobutane, answer is 3. That is 1 1, 1 2 and 1 3. This is 2 hydrogen is replaced from this position, 1 1, 1 2 and 1 3. For cyclopentane, the answer is 3. That is 1 1, 1 2 and 1 3, because this position again 3, this is again 3. But in case of cyclohexane, the answer is 4, because 1 1, 1 2, 1 3 and 1 4. These two positions are same. These two positions are same. In case of methyl cyclopropane, answer is 5. 1 1, 1 2, 1 3, along with 2 3 and 3 3. If I say 1 2 3, don't think for nomenclature. For simplicity, I have taken 1 2 and 3. This is 1 1, 1 2, 1 and 3, along with 2 3 and 3 3. So answer is 5. For benzene, it is 1 2, that is ortho, 1 3 meta, and 1 4 para. For biphenyl, this is 1 2 3 4 5 6 7 8 9 10, or you can say 1 2 3 4 5 6. For this also 1 2 3 4 5 or 6. So answer is 12, that is 2 3 2 4 2 5 2 6, along with 2 2 2 3 and 2 4, because these positions are same, along with 3 4 3 5, with take this position 3 and in this ring this is 3, so 3 3 along with 3 4 is possible, and again para para, that is 4 position possible. So answer is 12. For naphthalene, this position is called as 1 2 3 4 5 6 7 and 8. So answer is 12, that is position will be 1 2 1 3 1 4 1 5 1 6 1 7 1 8, that is fixed one position, 1 chloro, then 1 chloro 2 3 4, that is 1 2 1 3 1 4 1 5 1 6 1 7 1 8, along with 2 3 2 6 and 2 7. So answer will be 10. For anthracene, the value will be 13. Positions are 1 2 1 3 1 4. In anthracene, this is called as 1 2 3 4. This one is 5 6 7 8, and these positions 9 and 10. So 1 fixed Cl over this position, 1, this is 2, so 1 2 1 3 1 4 1 5 1 6 1 7 1 8 1 9 and 1 10, along with this is 2 2 3 2 6 2 7, along with 9 and 10. So answer will be 13. In case of phenanthrene, the value is very large. In phenanthrene, this position is called as 1 2 3 4 5 6 7 8 9 and 10. So if you replace this hydrogen with Cl, that is 1 chloro, and replace one by one the hydrogens of other place, you will get 1 2 1 3 1 4 1 5 1 6 1 7 1 8 1 9 1 and 10, along with this is 2 2 3 2 4 2 5 2 6 2 7 2 9 and 2 10, with 3 4 3 5 3 6 3 9 and 3 10, and 4 5 4 9 4 10 and 4 9 10. This position is called as 9, this is 10. So total answer is 25. Find the total number of trichloro products obtained from following compounds. In case of ethane, answer is 2, that is 1 1 1. Replace all the hydrogen of this position with Cl, or replace one hydrogen from this position, that is 1 1 2. So answer is 2. For this compound propane, the answer is 5. Position may be 1 1 1 1 1 2 1 1 3 1 2 2 1 2 3. In case of butane, answer is 9. This is 1 2 3 and 4. So answer came from 1 1 1 1 1 1, all hydrogen of this position, then replace one hydrogen from this 1 1 2 1 1 3 1 1 4, with 1 2 2 1 2 3 and 1 2 4, along with 1 3 3 and 2 2 3. So answer is 9. For this molecule, this is 1, 2, 3 and 4, and this is 1 dash for sake of simplicity. The answer will be 12. That is 111, all the hydrogen of this position, 112, 113, 114, or 111 dash, 1, 2, 3, or 1, 2, 4, or 1, 2, 1 dash, 1, 3, 4, or 1, 3, 1 dash, 1, 4, 1 dash, or 2, 3, 3. So answer is 12. For pentane, the answer is lost and it is 16. Carefully analyze. This position is 1, 2, 3, 4 and 5. So 111, 112, 113, 114, 115. With 122, 123, 124, 125, 133, 134, 135, 144, and now 223, 224, and 233. So answer is 16. For cyclopropane, 11, 1, 2, or 1, 2 and 3. So answer is 2. For cyclobutane, the answer is 3. That is 1, 2 and 3. So 1, 1, 2, 1, 1, 3, 1, 1, 2 or 1, 1, 3 along with 1, 2, 3. For cyclopentane, answer is 4. That is 1, 1, 2, 1, 1, 3, 1, 2, 3, 1, 2, 4. This is 1, 2, 3 and 4, 5. For cyclohexane, answer is 6. Position may be 1, 1, 2, 1, 1, 3, 1, 1, 4 or 1, 2, 3, 1, 2, 4 or 1, 3 and 5. So answer is 6. For methyl cyclopropane, the answer is 7. For the sake of simplicity, I have taken 1, 2 and 3. So position will be 1, 1, 1, 1, 1, 2, 1, 1, 3 or 1, 2, 3 or 1, 3, 3 or 2, 3, 3 or 3, 3, 4. Last, in case of benzene, it is 1, 2, 3 or 1, 2, 4 or 1, 3 and 5. So 1, 2, 3, 1, 2, 4 and 1, 2, 5. There are 3 trichlorobenzenes are possible. So these are 10 questions. A student can mail their doubt related to theoretical organic chemistry. I will solve those and mail the solution on my free time, so as to remove the fever of this interesting and lovable subject.